All right, everybody, so the second part of today's lesson, we're going to be looking at kites. So not the things necessarily that we fly in the sky. It does have a pretty similar shape to them, but there are some definitive properties about kites as a shape. So what is a kite? How do we define that in geometry and math terms? So they have two pairs of congruent sides. So let's draw that first. So a quadrilateral, I want to make that kite shape here. So this side and this side are equal, that side and that side are equal. So there are two pairs of congruent sides. Additionally, kites have one pair of congruent angles. And typically we're going to see that those come here, kind of like in between those two pairs. Okay, so we represented that, and let's color code this so you can see. So we'll put those in green there. Those are the congruent sides. Congruent angles, we can put those in blue. And then the last thing that we know about them is that they have perpendicular diagonals. So if we go from angle to angle and angle to angle here, we know that they intersect at a 90-degree angle. That means it's perpendicular. So maybe we can highlight that one in yellow. So again, intersects in yellow there. All right, so those are basically the major properties of kites, and if we can keep those three properties straight, we can apply those to solving for some unknowns. So what are some common example type questions that we might see for kites? So the first type of thing that we might see is as follows. Maybe this time the kite is kind of on its side. So there are the pairs of sides. And maybe we're given something like 80 and 50 for these angles. And what they want us to do is they want us to solve for angle X and for angle Y. Now we know, first things first, that they have one pair of congruent angles, so angle X equals angle Y. We know that those two things have to be the same based off of the properties of a kite. So we can take that information and do a part plus part plus part equals whole. So it's a quadrilateral, all angles add up to 360. So 80 and 50 and X and Y, all of those things go together to add up to 360. Just like we did above, put those like terms together. Let's move everything over. I got 230 here, X plus Y here. And then the last thing is we know that X equals Y. So we can take this Y out and put an X in its place. So 230 equals X plus X, or we can just say that that's 2X. And then the last step, divide everything by 2. So X equals 115. And if X equals 115, then we know that Y equals 115. So that honestly is going to be a pretty typical trapezoid question where you're going to have to solve for some angle measures. So something to think about there. And again, honestly, I would do a second example here, and I can do one, but it's going to be almost identical in its setup. So I'll call this example number 2. Not too much is going to change here in terms of how we go about these questions. So maybe this time we'll make our kite like this. And maybe this one is 100, and this one is 80. And again, we need to solve for X and Y, this time with different numbers. So add up all of your angles and set them equal to 360. Put together like terms. Combine those like terms. We know, just like above, that angle X equals angle Y, so we can substitute. Because again, it is a kite, which means if they are opposite from each other, they have to equal each other. Or we have one pair of congruent angles, I should say rather. Divide by 2, X equals 90, so Y also equals 90. All right, so for kites, remember those three properties that we highlighted above. I would say additionally, remember this framework where you add up all four of those angles to get to 360. And then kind of the key piece here is the substitution step, basically plugging in and knowing that those two angles, you have to have at least one pair of angles that equal each other.